Hello everyone, this is the video based on my assignment topic SEM technique, where SEM stands for Scanning Electron Microscope. The contents of these videos are the scanning electron microscope, principle, its construction, advantages, disadvantages, and its application. First of all, let us know what a scanning electron microscope is. A scanning electron microscope is a type of electron microscope that produces images of a sample by scanning the surface with a focused beam of electrons. The electrons interact with atoms in the sample, producing various signals that contain information about the surface topography and composition of the sample. The electron beam is scanned in the raster's scan pattern, and a position of the beam is combined with the intensity of the detected signal to produce an image. Let us begin with the principle of scanning electron microscope. The basic principle is that a beam of electrons is generated by a suitable source, typically a tungsten filament or a field emission gun. The electron beam is accelerated through a high voltage and passed through a system of apertures and electromagnetic lenses to produce a thin beam of electrons. Then the beam scans the surface of the specimen. Electrons are emitted from the specimen by the action of the scanning beam and collected by a suitable position detector. For the construction of the scanning electron microscope, some of the basic components are as following: electron gun, condenser lenses, objective aperture, scan coils, chamber, detectors, computer hardware and software. SEM works. The SEM uses electrons instead of light to form an image. A beam of electrons is produced at the top of the microscope by heating of a metallic filament. The electron beam follows a vertical path to the column of the microscope. It makes its way through the electromagnetic lenses, which focus and direct the beam down towards the sample. Once it hits the sample, other electrons are ejected from the sample. Detectors collect the secondary or backscattered electrons and convert them into the signal that is sent to a viewing screen similar to the one in an ordinary television, producing an image. Some of the characteristics information of SEM are topography, the surface features of an object or how it looks, its texture, direct relation between these features and materials properties; morphology, the shape and size of the particles making up the object, direct relation between these structures and materials properties; composition, the elements and compounds that the object is composed of and the relative amount of them, direct relationship between composition and material properties; crystallographic information, how the atoms are arranged in an object, direct relation between them are arranged, and materials properties. Electron guns. There are two types of electron guns. One, thermionic guns, and another one is field emission guns. Thermionic guns. They are the most common type. Apply thermal energy to the filament to coax electron away from the gun and towards the specimen under the examination. They are usually made up of tungsten, which has a high melting point. Another one is field emission gun. Create a strong electrical field to pull electron away from the atoms they are associated with. Electron guns are located either at the very top or at the very bottom of a SEM and fire a beam of electrons at the object under examination. These electrons don't naturally go where they need to, however, which gets us the next component of SEM. Condenser lenses. Just like optical microscopes, SEMS uses condenser lenses to produce clear and detailed image. The condenser lenses in this device, however, work differently. For one thing, they are not made of glasses. Instead, the condenser lenses are made of magnets capable of bending the path of electrons. By doing so, the condenser lenses focus and controls the electron beam, ensuring that the electrons end up precisely where they need to go. Objective aperture. The objective aperture arm fits above the objective lens in the SEM. It is a metal rod that holds a thin plate of metal containing 4 holes. By moving the arm in and out, different sized holes can be put into the beam path. An aperture holder. This arm holds a thin metal stripe with different sized holes that line up with the larger holes. The metal stripe is called aperture stripe. Chamber. The sample chamber of an SEM is where researchers place the specimen that they are examining, because the specimen must be kept extremely still for the microscope to produce clear images. The sample chambers must be very sturdy and insulated from vibrations. In fact, SEMs are so sensitive to vibrations that they are often installed on the ground floor of the building. They also manipulate the specimen, placing it at different angles and moving it so that researchers don't have to constantly remount the object to take different images. Secondary electrons. They are generated from the collision between the incoming electrons and the loosely bounded outer electrons. They are low energy electrons. Only secondary electrons generated close to surface escape. Backscattered electrons. A fraction of the incident electrons is retarded by the electromagnetic field of the nucleus, and if the scattering angle is greater than 180 degrees, the electron can escape from the surface. They are usually high energy electrons. They are fewer backscattered electrons than secondary electrons. Detectors. Various types of detectors are there in SEM. This device detects the various ways that the electron beam interacts with the sample object. For instance, Everhard-Thornley detectors register secondary electrons, which are electrons dislodged from the outer surface of a specimen. These detectors are capable of producing the most detailed image of an object surface. Other detectors, such as backscattered electron detectors and X-ray detectors, can tell researchers about the composition of a substance. Vacuum chamber. SEMs require a vacuum to operate. Without a vacuum, the electron beam generated by the electron gun would encounter constant interference from air particles in the atmosphere. Not only would these particles block the path of the electron beam, they would also be knocked out of the air and onto the specimen, which would distort the surface of the specimen. Advantages. Advantages of a scanning electron microscope includes its wide array of applications, the detailed three-dimensional and topographical imaging, and the versatile information garnered from different detectors. SEMs are also easy to operate with the proper training, and advances in computer technology and associated software making operation user-friendly. Although all samples must be prepared before placed in the vacuum chamber, most SEM samples require minimal preparation action. Disadvantages. The disadvantages of a scanning electron microscope start with the size and cost. SEMs are expensive, large, and must be housed in an area free of any possible electric, magnetic, or vibration interference. Maintenance involves keeping a steady voltage, currents to magnetic coils, and circulation of cool water. SEMs are limited to solid, inorganic sample, small enough to fit inside the vacuum chamber that can handle moderate vacuum pressure. Applications. SEMs have a variety of applications in a number of scientific and industry-related fields, especially where characterizations of solid materials is beneficial. In addition to topographical, morphological, and compositional information, a scanning electron microscope can detect and analyze surface fractures, provide information in microstructures, examine surface contamination, reveal spatial variations in chemistry compositions, provide qualitative chemical analysis, and identify crystalline structures. In addition, SEMs have practical industrial and technological applications such as semiconductor inspection, production line of minuscule products, and assembly of microchips for computers. SEM can be an essential resource tool in fields such as scientific, geomology, medical, and forensic science metallurgy. Thank you.